So this is a video for homework for number 8. So in this one, you're given a contingency table. Now a contingency table just gives you a ton of information in tabular form, where as you look across, you have rows that in this case represent white and black. And in the columns represent smokers, non-smokers. Then you also have the row totals and the column totals, which is nice that they actually give those to you. Not all contingency tables will give you the totals, but this is super helpful in this particular problem. So we're going to go ahead and we're going to find all of these probabilities. Now I know it might seem daunting, but you actually have all the information you need right in the table. You just need to know what all these symbols mean, okay? And that's why it's easier to explain this, I think, talking through it rather than going ahead and just writing it out. So first of all, the first one they want is the probability of S, which is the probability you had a smoker. So to find that, you just want to find out how many smokers you have out of the total in the table. So a lot of these, and it's not going to be every single one, but a lot of these, the total you're going to be using, or the denominator, is going to be 1,000, because that's how many people are actually in this table. So all we need to find, that's going to be our denominator, but all we need to find is the number of smokers that we have. So we're going to look at our table. We're going to go to the number of smokers. I'm going to go down and say, oh, the total number of smokers, and this is total because they're not specifying white or black, they're just saying smokers, is 298. So to get this particular number, we just take 298 and we divide by 1,000. Now just be careful because they want you to round to 4 decimal places. And sometimes people think, oh, the last number is 0, I don't need it. But if they're saying that you need to round to 4 decimal places, you need 4 decimal places. So you will get it wrong if you only put 0.298. So make sure that you have that 0, even though it seems, not necessary. It's necessary for you to get the problem right. So you're just going to take 298, divide by 1,000, meaning move it 3 places to the left. Really easy. Divided by 1,000 is just move it 3 places to the left, decimal point, and you get 0.298. Don't forget to add the 0. Okay? So that is your first one. Okay, let me just erase this. For my second one, I'm going to keep the 1,000 here, so I'm not going to erase that. But we want the probability of white. So again, they're not saying a white smoker or a white non-smoker, just all the white. So we're going to go ahead and we're going to say, what is the total number of white? Go all the way across, and we have 805 is my total. So we're going to take 805, divide by 1,000. Again, just move this decimal point right here at the end. It's not showing yet. 3 places to the left. I'm sorry. And then go ahead and, I think I may have just been saying right. I think I'm just very tired. Move 3 places to the left. And again, we want 4 decimal places, so make sure that you add a 0 at the end. Okay, so that's that one. Now, the next 2 are a little different because we're not going to be using this 1,000 as our total, because these are what we call given problems. So what this notation means is they want the probability of a smoker, probability of S, smoker, given that the person is white. So what we're going to do is we're going to only look, think of this, second contingent event here is what it is, as we're only going to be looking at that part of the table. So for this problem, and again, excuse my wiggly line because I'm using my mouse here, but for this particular problem, we're only looking at this part of the table. We're not even going to look at the rest of it. So we're not using those totals either. So we want the first thing's going to go on the top. So my smoker will go on the top, 286. And then my total white is going to go on the bottom because that's the total number of people in that category. So the 805 is going to go on the bottom here. And again, just make sure that when you do this calculation, 286 over 805, that you make sure you round to 4 decimal places. So we're going to get 0.3553. Okay, now for the next one, let me just erase these. For the next one, we are using, or we want, I should say, the probability of a smoker given black. So again, I'm going to ignore the rest of the table, and I'm only working with this row, not looking at anything else. So in this case, smoker is only 12 of them. And my total is 195. So it's going to be 12 over 195. So you're going to go ahead and you're going to divide 12 divided by 195. And again, make sure to round to 4 decimal places. So we're going to get 0.0615. Okay, so that's how you get those 2 answers. Again, whenever you have that given, this little symbol right here, we just say given in mathematics. You're only going to be dealing with that particular column or row, in this case row. Okay, let me clear this off. Now next we want the two probabilities of and. Now and in mathematics, you can use a couple different ways. Sometimes they use the word and, sometimes they use the symbol intersect. So the other way that we could go ahead and we could write this is I could write it as the probability of S, again, sorry for my handwriting, intersect, which is that downward U, right? And intersect W. So we want where both of them occur. And again, this time it's going to be out of the total. So we're going to be using the 1,000 as our denominator for both of these. So S and W, where do those intersect? So smoker, white smoker, right there. This is the number I'm going to look at. Those are the white smokers. Okay, so they have to be both in order to be in this category. So the probability you have a white smoker is 286 out of 1,000. And again, move 3 places to the left. I hope I was saying left in the beginning. I'm not sure if I was. And add that 0 because we want 4 decimal places. Okay. Then for the next one, we want the probability of non-smoker and black. So we're going to go ahead and find the black non-smokers. Black non-smoker, here is where they intersect. Those are the black non-smokers. 183 out of 1,000, divide those two, and we get 0.1830. Now the next question, that was all your probabilities. Do you see evidence that smoking and race are not independent? Now the whole deal with independence is a little formula here, right? We want, if these two events were independent, we'd have the probability of A and B. I'm just going to use A and B as generic terms. So that could be A intersect B or A and B. I'm just going to use A and B because people prefer that over the scary probability things, is going to equal the probability of A times the probability of B. That's if they are independent. Okay, so if they are equal, they are independent. If they are not equal, then they are not independent, and instead we call them dependent. Now the key is, how do we find this probability? Okay, given that we have a contingency table, we're going to do the same thing we just did. We're going to go ahead and find out just where we have that intersection point. Okay, so let's go ahead and talk about, are they independent or not? Let me just go ahead and erase these so we have stuff out of the way. Okay, so smoking and race are not independent. So we want to say, let's talk about, for example, smoking and white. Okay, so let's look at smoking and white first because we already calculated that probability. Does 0.2860, because that was smoking and white, okay, equal the probability of, instead of A and B, so we did smoking and white, the probability of being a smoker. So what was the probability of being a smoker? 0.298. So 0.298, okay, times the probability of being, again, smoking and race, we're doing, this was, I'm sorry, we were using smoking and white. So what's the probability of being white, which was 0.805. So I'm going to put 0.805805. And again, sorry for my calculations here. So we got to do 0.298 times 0.805. So let me go to my Google calculator. Let me just share that with you. So 0.298 times 0.805 would help if I have my correct pointer here so I can actually share. Okay, so 0.298 times 0.805. Well, look at that. I already had it up there because I did it earlier. Times 0.805. Oh, I'm getting 0.239. Now, did that equal what I had before? Let's go check. So let's look at what we had here. So originally we had the probability of smoking and white was 0.286, so that does not equal what I just got in my Google calculator. So these are not independent, they would be considered dependent. Now you could also check smoking and black, but we already did smoking and white, and I'm going to assume smoking and black would do the same thing. So we see evidence that they are not independent because those two things, the intersection and then the probability of two events being multiplied together, were not equal. So yes. Now, why might public health officials be interested in this type of data? Well, it's not that they're not interested, right? Health officials might target or design special programs based on race. Yes, that could happen. The next one was health officials can use this as an excuse to explain the lack of initiatives to curb smoking. Well, I'm not sure if they would do that, because then they would probably be accused of being, gearing towards one or the other, either white or black. So I think we would go here. Health officials might target or assign special programs based on race. Can we, help the white people that are smoking, help the black people that are smoking? And I think that's the particular answer that they want. So let me know if you have any questions on that. I think the hardest part was probably just finding those probabilities. But if you have any questions about independence, just let me know.